me.
Yes. Can I record you? Can I record this?
Yeah, go ahead. Yeah, go ahead and record me.
Cool.
Just no leaking it until I present it Sunday. But if I die before then you can make a video on it.
That's what Bob Lazar said. So.
Yeah, exactly. Right.
Don't use that tactic.
Right. Well, I'll get a tripod then.
Okay.
You carry on.
So here's the deal. We've been catching flack on the 8 inches per mile squared because they say it's not based on a geodesic calculation, and then you've seen them come out and use this, saying that this is the proper way to actually do it because this is based on geodesy, correct? So I was thinking to myself that, looking at all these different math types that I've been looking at, that it seems to me that there should be a correlation between the distance to horizon and also the 8 inches per mile squared, if they're accurate. So here's what I did. Let's do a completely different one. We've already done this a couple times, once from 12,000, once from 17,000. So far it's worked out perfectly both times. Let's take it at 23,000 feet this time. Okay, in feet, and the distance to the horizon is 185.9 miles, okay? So then we take our calculator here, and we're going to say 185.9 times 185.9 equals, okay, times 8 inches. Okay, that's the distance in feet of the curvature. And if we divide that by 12, or in inches, I'm sorry, and we divide that by 12, then we have it in feet. And we've got 23,039.20 as compared to 23,000 here. Now, the true measurement is 7.99 something, and I can't recall it, I'm gonna have to look it up, but it's 8 inches per mile squared is a round up, but it's more like 7.99 or 95 inches, something like that. Anyway, if you put that in and multiply this distance squared and multiply it times the 7.96 or something, it's probably going to come out dead nuts on the 23,000 feet, okay? So the distance to horizon calculator matches precisely, for all intents and purposes, the 8 inches per mile squared formula that we're using to calculate the curvature, except that the distance to horizon calculator is using a geodesic, and they arrive at exactly the same conclusion. So I kind of thought that was significant, and I was looking for anybody to poke holes in it. Any thoughts?
Right.
Oh, and here's the other thing. Let me show you one other thing too, really quick. If we take, this one we don't even need the calculator for. If we take, we're looking for the distance of horizon, well, what is the distance horizon if you're only at 8 inches? And 8 inches would be 0.666 feet. And of course, it proves itself out at 1 mile. So it's confirmation, from one model to another, geodesic to standard trigonometry. And I just thought that was, an amazing correlation.
Very cool. Very.
Yeah, I mean, one of the interesting things that I came across recently was when you, if you can use like 16 inches times the mile squared over 3,959 miles, the radius of the Earth, it works out to be, there's a drop of 3,959 miles, which is curious, at 16 inches times the mile squared. So there you're having like a square of the radius, basically.
Yeah, and that's one of the other things that's been coming up a lot is, and they're saying that if the radius of the Earth is 3959, then shouldn't that be the drop in curvature as well for 90 degrees of curvature, or essentially 6,500 miles, roughly 6,200 miles, maybe.
Yeah.
Yeah. So.
It's a strange anomaly. I mean, I think the 8 inches times a mile squared mathematics works up until a certain extent for some reason.
Yeah, until you go past 90 degrees, then it's actually coming back on itself and it's no longer valid. So you can only use that for a maximum of about 6,200 miles, whatever quarter of the circumference of the Earth is, because after you reach 90 degrees from the point that you're standing, then that curve comes back underneath you, and that invalidates the entire argument of the curve, right? At least that's the way I'm seeing it. Yeah, okay, so...
It sounds sort of correct. Yeah, I mean, from what I can see, it's like maybe 45 degrees. It might look that 8 inches times the mile square might work up to 45 degrees of the 90, but beyond that, it also depends whether you're measuring it from like a vertical height down, or there's different equations, and you start to get a little bit different depending on the angle from the tangent line.
Yeah, so we have to bear in mind that what they're measuring is something that isn't there. So what they're measuring and what the theories and the mathematical equations are there to kind of try to explain is something that's not reality. That's why it breaks down at certain points. That's why there are these discrepancies. It's because they're measuring something that's not there. So they have to use non-Euclidean mathematics. Otherwise, they have no... Because they've said we're on a globe, they then have to have something to express this in a mathematical way, and they're expressing something that's false. So the mathematics breaks down, as we just saw.
Yeah, I mean, I don't know why the mathematics breaks down, but I mean, from what I've observed doing my experiments, I mean, I've done a lot of experiments this year, and one of them was where I was like laying on the beach, less than 1 foot above sea level, and with my camera on the pebbles, on the wet pebbles and that, and a very calm day, filming boats that appeared to be looming. They call it looming. They're like floating in the sky, but they weren't, because the conditions were perfect that I could capture the sea underneath the boats and everything like that. And the boats were about 4 to 5 miles away, and I could do a comparison on the zoom, maximum zoom on my camera to an object here that I know are 5 miles away. So these distances, I'm seeing the bottoms of the boats, and I'm seeing my horizon isn't, because I'm 1 foot off the ground. Yeah, from the camera, that my horizon should be 1.2 miles, and I can see all the way to the bottoms of the boats, which are 4 to 5 miles away, on a perfectly cut sea. Yeah.
Well, this is how the mathematics breaks down, because the mathematics says no further than this point. It's because they're describing something that is real. This is it. We have to remember they are describing something through pataphysics, the physics of the non-existent. Like everybody, you all have to go to Wikipedia and look up pataphysics. Look at what it's expressing, and it's a joke. It's an absurdist thing. But when you look at it and you then look at theoretical physics, now you'll see that it's pataphysics. It's the physics of the imagined, the fantastical, and the non-real.
I forgot the word now, sorry.
Right. So, Antonio, I was thinking of something, and I want to ask you guys this. So, when I'm looking at like calculating distances to horizon, and that would work if we're standing on a beach watching a boat go away and stuff like that. But it seems to me that distance to horizon calculation also very much seems to factor in average human perception and average human eyesight factors. And the reason that I say that is because the distance to horizon is supposedly what we can see out to, the edge of the horizon. I'm 6'5", and so I can see, a certain degree out to the horizon. What is it? I can't remember the exact distance, but anyway.
3 miles. 3 miles.
Yeah, 3.5 miles, something like that. But that's obviously, I know that I can see much further than that if I use some sort of magnification optics, like a zoom on a telephoto lens or a telescope. So that tells me that somehow that distance to horizon equation must also, or it seems to me that must also take into consideration human perceptions, average general human perceptions, right? Otherwise, what if we had, telephoto lens, then that distance to horizon figure would be wrong.
I'd like to add something in, Bob. You're looking at perception as 1 or 2 dimensional, and you're not really understanding that light is 4-dimensional. But if we talk about just 3-dimensional space and what we observe, the horizon might be at such a spot in your perspective, but you might have objects that are further past that spot still visible because of their light range that they're viewing back at you from. That's why the problem with calculating buildings that have floors dropped off, it's invalid for two reasons. One, I can explain, is just because the light from the sun is curving down and then bouncing and curving down again. So,
what do you mean bouncing off of what?
Off the
the
building
upper
in the
aperture?
distance.
Okay, I
Yeah.
gotcha.
Yeah, so because you're talking about how far you can see, but you can see ships once they're past that perspective, right? I think Matrix said he had ships that looked like they were looming.
Yeah, and I think that there's definitely going to be variances in perception from person to person. But I'm just saying that overall, you know, the average person, like if you and I, if you have average eyesight and I have average eyesight, and we're both standing on the shore and we're both seeing this ship at the very edge of our perception, well, I guess that would be factored in on two things. One, its size also, as well as the distance away. So maybe I need to think that a little bit.
I'm gonna screen share a graphic
Okay.
while we talk. But somebody go ahead, sorry.
Oh no, don't screen share, it'll go wrong.
If I can just throw this in. So perspective, like you said, Bob, is based on eyesight, and your eyesight linked to your indexical point of view. So you're standing and your eyes are maybe 4 inches away from the top of your head. So, you don't have to calculate the distance on the pataphysics map description of the curvature. You can see a certain distance in certain climates. Now, in different climates, from the same standpoint, you will see further. There will be times at night where you can see much, much further, times at night where you will not see much further, and there's all kinds of elements that work together. So when we look at a theory or an idea, and we don't include all the extra elements, like Ronnie's suggesting, the element of light bouncing, which is, an integral part of sight. But there's also other elements like atmosphere. So when Matrix is explaining the looming, if you look at some of his footage where there's no looming, where there's the land in the distance and a pier and a lighthouse, but if you look at that footage and you look at the ocean just below this landmass, you see that the ocean is already starting to take the same color as the sky. So when you then move and look past that point, so further away, you can see the portion of the ocean that is reflecting the sky between the ship that's looming and the portion of the ocean that's no longer reflecting the sky. And it is literally the same color. So if we take this same phenomenon and we place ourselves in the desert, we will have something similar in the distance. If we place ourselves in the salt lakes, in the flats, in the salt. So there's a whole combination of elements that have to be included to us looking, just seeing. And what the pataphysics do is they say, this is the curvature. The only elements that have to be included is elevation and distance. They don't include the atmosphere. Later, when there's a criticism, they include atmosphere. But they keep adding onto it to try to define away the curve. Because when you can see further beyond the curve, like we all know, is actually demonstrating that the curve is not there. It's not a case that the light is bouncing from beyond the curve and then somehow bouncing back towards us. It's literally just an expression of their stopgapping. The people explaining the curvature are stopgapping. Because there isn't any curvature.
Right. Yeah. Well, yeah, and I totally understand where you're coming from there, also. But I guess one of the things that I was kind of where I was going with that was, our perspective as far as the ways that our eyes actually operate.
Yeah.
And when you think about it, your eyes operate just like a gyroscope. For example, if you focus on a flat surface like your computer monitor in front of you and you focus across the horizontal line on the top of it and you tilt your head from left to right and your eyes aren't really moving, but your brain is adjusting gyroscopically to keep that that line, that horizon line across the top of your monitor in exactly the same perspective as you cock your head back and forth.
Yes. In fact, Bob, we have the cochlea in the ear, which works in conjunction with sight to tell us angle, attitude. So this is what makes people be travel sick. You know, children who get travel sick in cars.
Right.
It's because the visuals are not corresponding to the cochlea. There's a discrepancy.
That's where vertigo comes from, right?
That's exactly, yeah. So yeah, you're spot on. Yeah, definitely.
Yeah. So anyway, I was just thinking of it, that way, and that's one of the built-in mechanisms of our perception that is very mechanical-like to me, almost. Just like a camera lens or something. It's amazing, but nevertheless, you think about it, and that's actually how your eyes are working, is gyroscopically as well. And getting back to the whole gyroscopic proof that I was talking to about before, it seems to me that you couldn't use a gyroscope at all for navigation on a curved Earth, on a ball Earth. It would completely screw it up. Think about that for a minute. How could it ever work?
Well, just like a compass really wouldn't work, right?
Right. And the compass, and the reason that compasses have anomalies is because the magnetic field, as it comes down around 67 south or 70 south, wherever, for the south and north poles, it's actually coming down perpendicular to the compass needle. It's literally pressuring down the back of the compass needle, and it makes it inaccurate. So you have to compensate for it by overly tilting, one direction or another, so that you can keep the needle on a somewhat free spinning, central point, pivot point. So yeah, you're exactly right. It's just like a compass.
Hey Bob, I gotta sort of interrupt. That's an excellent point. I know some people that served in the military. I learned this one thing that like paratroopers or people that jump out of planes, usually they signal each other with like compass mirrors.
Mm-hmm.
And what I was thinking was, if anyone wants to ever try to do another curvature test, during the day, at midday, you would use the mirror, because I think I read somewhere that it has up to 150 miles. I don't know. Don't quote me on that. But the reflection, because planes can spot you easily from the sky, right?
Oh, I'd say 150 miles would be a piece of cake for a sun in a mirror.
If you're thinking upwards, right? So I just thought that might be an interesting way to calibrate a test. I don't know if anyone's ever done that or heard of that.
It would be a little chaotic in a free fall, but I get your idea.
Just one guy on the edge of the shore there, and the other guy you could probably get 50 miles.
Right. Well, it's kind of like what Jer and I want to do. I bought these flashlights that have some ridiculous 6,510 lumens. They're ridiculously bright. And we were kind of going the same direction. We figured if we had really, really super bright lights at nighttime, we should be able to see those at considerable distance. And that's kind of the same thing with sunlight. If you're taking, how many billion candle power the sun has, and projecting it out, through broad daylight, you're going to see that flash for a pretty considerable distance.
Yeah, in fact, Ronnie, you've just given me an idea for the next time I'm at the beach. So, how Jaron was using the laser, Bob?
Mm-hmm.
The laser test. So, obviously, you're doing it at night time so you can see the laser. Why not in broad daylight and use the sun, like you were saying?
Well, it'd be great, except it's going to be extremely tricky to get the angle just right. I mean, talk about a precision adjustment to pinpoint something a few miles away. It won't be easy, I can tell you that.
Yeah. But what I'm thinking is, I'm going to practice with a mirror. So if I know the person I'm doing this with is to my left, so I will put my hand towards where I think they are, and I'll just move the mirror around until it's flashing on my hand, and just keep moving it. It doesn't have to be aimed absolutely precisely. As long as they can see the flashing, then they can see the mirror.
Right.
Then, yeah, that's cool. But I tell you this though, I'm not sure how far the Balearic Islands are from Barcelona, but there are times when you can see the Balearic Islands from Barcelona, and they really definitely shouldn't be visible. So yeah, it's atmospheric conditions. So I would be doing this in the daytime. Next time I go to the beach, that's going to be cool.
Yep. And you know, one of the things that Jaron didn't do, and you know, if I wind up hooking up with him this summer, I'll take the blue laser because you know you guys know about the green laser I bought him, and
Yeah, the blue laser's better.
the blue laser, the blue laser is 3,000 milliwatts, or it's 3 watts. The green laser was only 1 watt, and the blue laser also has a lower divergence spec on it.
Green is good as well, but the blue is the best. And for what I build when I work, blue laser, you can see right in broad daylight.
Yeah, and so I'm thinking at night, and here's what Jaron didn't do because, and I can't blame him because I was the one that explicitly warned him about this. I told him, I said, Jaron, do not point that green laser at anybody's eye. I said, because if it hits their retina, it's going to go up like a flash cube, and I was dead serious about that, right? So he was completely freaked about it, and he didn't want to point it at the camera on the other side of the bay because he thought that the intensity would be so hot, even at that distance, it would fry somebody's retina, which it wouldn't, but he didn't know that, so I can't really blame him. But the point is I was trying to get him to understand that if he pointed the laser, you know, from maybe 8 inches above the ground directly across the ocean or a foot above, whatever, directly at the camera, and the camera could see that very clearly, then what you're doing essentially is taking the optics more to the laser than you are the laser, or having them meet somewhere in between in the middle. And beam divergence didn't matter that much because you were taking the optics to a focal point on the laser that was still far from being diverged out to that 10-foot divergence that, you know, Missa found on the other side. Yeah. So he never did that. And you know, that and not only is the blue laser 3 dB hotter, because it's a little more than that, it's about 6 dB hotter on the light wave, but it also has that blue light, which does not diverge nearly as much as a green light, so it's a far better light for the test.
Brilliant. So I'm going to get me one of these. Do you know, I don't know about you guys, but I'm looking forward to the next time I'm on holiday on the beach, just watching how many people are making experiments.
Probably none, just you, to be honest.
No, I don't know. I think, you know, I'm going to go to a beach at some point where there's a lot of people, you know, people from Madrid emigrate to this area in the summer for August. There will be a lot of people there, and I'm kind of expecting that. In fact, what I'll do is I'll make a video of, you know, I won't know who's doing the experiments, but it'd be interesting to see, oh, look, there's somebody else shining a laser out horizontally, and there's somebody over there. And
you would instantly be able to go and talk with them, and they'd be like right on the same page as you. You know, Bob, what you were saying about the laser and Missa and that test, doesn't it seem like, because the way Flat Earth is, that was a really long time ago?
It really does.
But it was. I remember
like
watching
6,
those
7 months
videos
ago.
live, and then couldn't find Jared, and then the police and the whole thing, like as it went down.
The crazy troll.
Yeah,
that was about 10 months ago, actually, 9 or 10 months ago.
Seems like a couple of years ago.
I know, it seems like a long time.
It was a different time. I remember trying to get him to shine the laser on the moon, and then I was going to see if I could see the laser shining on the moon from
I
Toronto.
wasn't making videos then. So, yeah, funny.
Yeah, that would have been amazing if you could have seen the laser on the moon from Toronto.
That's what I was thinking, Bob. I had it screen captured and everything. I'm like, this is going to be great.
Some guy was saying that he tried to tell on Facebook. He messaged me and he asked me for advice on how to talk to people about Flat Earth and his family. He said his brother-in-law was telling him that you can use binoculars and see footprints on the moon. I said, you're probably not going to have any luck with that guy because there's a long way for him to go.
I find saying everything but Flat Earth, or, you know, I found that's a really good way to entice people into thinking.
Yeah, but they still take it back eventually. They make the connection. Oh, you're talking about Flat Earth, right?
Obama warned me about you.
Yeah, I like the term Flat Earth because it's a shock factor.
Yeah, I like it.
Impact. You know, it's got impact. It's like a real anti-system.
I am exactly the same way, Matrix. I like to lead with the outrageous.
Yep.
I love it. I mean, it works for me, you know.
Hey, has anybody else noticed lately the sun acting really curvy?
Acting really
Found the
curvy.
curvature?
Curvy.
Oh.
We haven't
But
seen it lately.
It's been strange for me. The sun rises and it stays in my upper zenith, like, you know, quite close to being at my midday for like 4 or 5 hours, and then it like curves to the right instead. It's really odd.
Huh. A
Are
lot of
these
people
new
have been saying
things,
that.
or are we just noticing it? That's
Mhm.
I don't know.
we're just noticing it. Otherwise, it would be in the mainstream, maybe.
Is Nathan still with us?
Yeah, you don't see me.
No, all I see is
Turn
this
your
little
camera off.
going
I
around
think.
in a circle on your.
Yeah.
Yeah, if you turn your camera off and on again, Nathan.
Yep,
He looked frozen, but he was probably just not moving.
Yeah, he was just had the little thing going around in a circle.
Oh, I was able to see him. It's weird
Oh,
how
really?
some of us can see each other and some can't.
Yeah, it's weird. Well, it's
I
all-
know that Bob, you've got yours off. Ronnie's is off. Ben's is off, and Nathan's is now off. So
For me, the only thing pretty much left that's round or anything odd is the star trails. That's pretty much it for me.
Okay.
Yeah. You haven't shared that with him, Antonio?
No, not yet.
Yeah, I'd almost wish you would do it again just so I could review it again because, I mean, honestly, that's huge.
Okay, I'm going to see if I can.
This is amazing, Ronnie.
Yeah.
This is, but the one I really want to evaluate this is Jaren or Cammie. Cammie's not here. I don't know where she went, but it's astounding. And I'm kind of spatially challenged as far as perceiving things in 3D. I'm nowhere near as good as my son Jaren, who's really good at it. You know, the kids that can, take a form and fold it in 3D space and tell you what the result is. I suck at that. So I wish I was a lot better at it. But
Have you practiced with the compass and the square? Sorry to interrupt. It might be, drawing shapes with it. It's really good practice. Sorry to interrupt you.
Yeah,
I'll-
no, we've
sorry,
done
I'll be
that.
back in 1 minute. I'll be back in 1 minute. Yeah, I'm just going to grab something. Yeah. Carry
No,
on,
sure,
please.
Matrix. No, actually, I tend to want to draw things, on my little scribble. That actually helps me. But you can't beat a good 3D graphics presentation. I mean, there's just,
Yeah, I know. So I can't do it. I've tried. I can't.
I know
I do
it's
better
hard.
with 3D graphics than somebody like using their body to
One
explain
second.
it to me, because then I get sort of lost.
Yep.
So I'm trying to find a good video. I can tell you both an exercise, a visual exercise, a perception exercise for drawing. If you want to know, it's really simple, and it's something that you can do anytime that you can just doodle away. Do you want to hear it?
Sure.
Okay, this is an exercise. It's an old exercise, and it's for portraiture drawing or portraiture painting to gauge the distances between the eyebrows, the pupils, everything correctly. And it works on a principle of triangles. Okay, so
Right.
this is how you do the exercise. You have two pieces of paper, same size. You take one, you place a dot anywhere on that paper, and you place an X on that dot. Another dot anywhere on that paper. Oh, what's that?
Ben, can you mute? Can you
Oh,
mute?
sorry.
You mute your mic.
Someone's really loud.
It's been.
I thought I
Okay,
muted
so-
it.
So
I'm back now. Be quiet.
you place another dot, and from then on, any other dot that you place will make a triangle. So you have two dots, you place a third dot, now you have a triangle. You don't draw a straight line, you just have three dots. You then draw a fourth dot anywhere, and you see the triangle. And you make, basically it will look like constellations of dots, but you're always looking to place the next dot in order that it makes a triangle with the last two dots, okay? Once you've done that, you take the other piece of paper, you put it side by side, you place your first dot, so you're going to now copy what you've just done. You're going to find where the first dot is on the surface of the paper, you're going to put it there, put an X, and you're going to try to draw all the dots. They don't have to be in the same sequence, but you're looking for the triangle, okay? Anytime you're plotting a dot, you're going to try to make it reflect the triangle on the previous page. Once you've done this, so you have two sets of equal constellations, that's what they will look like. You place one paper on top of the other, you line up the dot with the X, and you look through the window, or you hold it up to light, and you will see how your dots misaligned. You will see the proximity, how close you were, and how your distortion happens, because we all have a distortion. And this is something that's necessary for portrait drawing so that we can accommodate that, we can redress that distortion.
Right.
Did I explain that well enough?
Yeah, I get the concept. Yeah, I definitely do.
Yeah.
It's kind of a diamond, triangular grid system, sort of.
That's it. And you can make it as structured or as chaotic as you want. And the exercise, the first series, which is just placing the dots, is not important. It's the second part of the exercise that's important, where you're trying to copy this. And what you'll find is, if you have your first, so let's call the first set of constellations the master, okay? If you have the master on the left, when you're copying on the paper to the right, you will have a different result as when you have the master to the right and you're copying on the left. This will tell you how your distortion works and how you see things more clearly, more correct. You might see things from your right more correctly than you see things from your left. So as an artist, you have to know this. So when I'm drawing a model, I know that if I have her to my left, I will get her more correct than if I have her to my right.
Interesting.
Yeah, but it's good when you do this, you then have a matrix in your mind with which you can use for conceptualizing.
Visual focusing techniques, I guess.
Yes, yeah, but you can then use it to visualize things. You don't have to think in terms of dots, but you've trained your mind to placing things. So when you're trying to visualize things, you can place them. It's cool.
It's kind of like in art class. I remember in junior high and high school where they would teach you to use a grid system to copy something, to kind of put everything in this grid system and matrix it off more or less so that you can make an accurate reproduction. But, I always sucked at art, so, I'm an engineer. What can I say?
But that grid system, that's just for it. Yeah, it's fine. It's a good way of illustrating that there are systems that you can use for artistic principles. But this one, the constellation drawing, is absolutely awesome because it shows you your distortion. So even with a grid system, you might find that you've taken a grid where the line enters at the top left corner and it stops short of the bottom right-hand corner on the bottom line. But the difference there is just slightly bigger than it is in the original. But unless you know this, everything else will be skewed. And this exercise with the dots helps you to see how your mind skews things. It's brilliant. It's a brilliant exercise. I do it anytime I have time, to just chill. It's a really good exercise. It's
amazing how faulty our perceptions actually are in so many ways, isn't it?
Yeah. But the thing is, when you've done this exercise maybe 10 times, as you're plotting the series of dots, you know that you want to plot it here, but you know that your mind distorts it and puts it up and to the right a bit too much. So you will place it down and to the left a tiny bit. And eventually you will get to the stage that I'm at now, where when I hold them one over the other, it looks like I'm just holding one sheet. They're spot on.
So you line the paper beside each other and copy one to your left and then copy it to the right by looking at the other drawing, the master. You don't overlay it and trace it. You have to literally...
No. The overlaying is just to see how your perception is distorting the information. So that's you lay it on one on top of the other, and you will see from when you're drawing left to right versus right to left, you will see the distortion. You will see that generally you distort up and to the right, or down and to the left, to the right. You'll find that all of the dots are shifting in a direction that you didn't expect. And when you draw the other way around, you'll find the same distortion but different. It's really interesting. And once you find how your mind distorts what you're seeing, you can compensate for it to the point where it won't distort what you're seeing in terms of representing it.
So Antonio, you're saying that, I missed the beginning part of this, but you're saying that the stars that people see, the circular path around Sigma Octantis, for instance, in the southern hemisphere, is an illusion.
No. It's what I was. I think you jumped in. What I was just explaining was to Bob for a visual exercise. So drawing. That was just one thing. Going back to the stars, which is what Ronnie was mentioning. And this vortex, this circular motion that they make, is false. They don't make a circular motion in the south. If you look,
is it from a fisheye lens, Nathan? Is that what's causing it?
No. Well, there's when you look at star trails of the southern hemisphere, you will find all these circles. When you look for aurora australis of the southern hemisphere, which is where the aurora australis happens, you will see the lines moving horizontally, and this is because they haven't, whoever it is, hasn't put it through a program to show spin.
Well, hang on. We need to establish then, because this information, there's two different things that both of you don't want publishing until other things happen. So get your disclaimers in.
Okay, so
yeah, agreed, Nathan.
Ben and Ronnie, what I'm doing is I've got a whole bunch of footage, amongst other from the ESA, and I have the equivalent footage not from the ESA but from the same latitude north of the northern stars. So I have footage of the southern stars and footage of the northern stars. The northern stars are rotating, same latitude, so 70 degrees north and south. The northern stars are making a smiley face across the sky. The southern stars are going straight across horizontally. And I have lots of this footage, which I'm not revealing until this is basically, I'm keeping this quiet to blow JLB away, because his biggest bone of contention is the southern stars. And any of you can go online and look for the aurora australis, and you will see that the stars move horizontally. So the reason the way I found this was by looking at footage of it's called the Halley 8 science station in Antarctica. And whilst watching this documentary about this science station in Antarctica, which has to be moved every year, there was a photograph behind somebody speaking, and the photograph was showing star trails moving horizontally. It was a poster behind her. And this made me, oh my God, these people know that they move sideways. So I need to find footage that shows this. So I was looking, and every bit of footage of the south was showing a curve. And then I thought, okay, how can what search can I do that will show stars that haven't been manipulated? So I thought the aurora australis, because people will not be paying attention to the stars, they'll be paying attention to the cool light. And when you do that, you see the stars moving horizontally. So this is a big blow for JLB and for globe skeptics, because there is no globeness. There's spin in the north around the northern star. There's no spin around the south, around any south pole. There is no spin whatsoever.
You know what, Antonio?
Sideways.
You know what I think we ought to do, Antonio?
What?
I think that you should give JLB a chance for rebuttal, and instead of dropping it on him during the debate, come on Sunday on Globebusters, and we'll drop all of our nukes at the same time.
Yeah. Well, I could add on there, because me and Matrix have been researching this heavily. I have as well. I've gone through all the star trail footage, all the YouTube videos of people creating star trails. Mm-hmm. I've seen time lapse. I've seen photograph turned into time lapse. We need somebody physically, somebody that we know, that we can vouch for specifically, to take the pictures. One every 10 minutes or one every half an hour in the south. And then the other question of contention is the direction of the viewer.
Yes.
You could rebut then, if you look south, it'll be straight. If you look north, it'll be curved. Because that is approximately what I see as well in the north.
If I give you a visual exercise, it's just.
I know they move like this, the stars.
Yeah.
I know. Yeah.
So Ben, if you picture an umbrella, one of those big golfing umbrellas, and you have the ribs that go across from the center hub to the edges. So let's say 4 inches from the center hub, you place ribbons hanging down, and you do the same on the very edges of the umbrella. So at the very ends of the ribs. Now you start turning this, you'll see that the top circle the top, make a circle. But when you look to the edge, even though you're rotating it at the same speed, the edge will be making a horizontal line. Now, this is what we have in the real world, and the top is moving clockwise. Sorry, the top is moving, clockwise, and in the south it's moving right to left. The whole idea that they move anti-clockwise is a myth. So I've got footage of the aurora borealis showing clockwise motion in the north, and the aurora australis showing the equivalent clockwise motion right to left.
Right.
It's gone.
They confuse it with the whole rotation thing. It's like looking at the top of a globe while you're spinning it, and if you spin it left to right or clockwise, and then keep it spinning, and then look at the bottom of the globe, and it's going counterclockwise. It's just an illusion of perspective.
Yes, and this is something that astronomers talk about, but obviously people aren't in both North Hemisphere and South Hemisphere. They're not there to verify them. They're just going to take and run with whatever they've been taught. But if you look at the footage where they're filming the light, not the stars are visible, but what they're filming is the light. That footage has not been modified. So I've pulled it all down. I've got it on my hard drive, just in case it freaking disappears. So this is what you see. It's just, the globe is dead, and the star constellations, the South Pole, Bob and I spoke about this ages ago. We said, this vortex at the South Pole, when people are saying they can see it from Australia, from South Africa, from South America, this is a big problem. And the truth is, it doesn't happen. This is the thing. It's just an illusion. It's a misrepresentation, a lie, a distortion. It doesn't happen. They move horizontally. So when you have the Crux constellation pointing to the south, that moves across the sky.
Yes, that's what I've seen.
Yes.
I can verify that. So is me, and you can see it up to what 78 degrees north.
28 degrees.
28. Yeah.
Yeah, and also what you said, Ronnie, about having verifiable footage that doesn't come from some anonymous source. We have somebody in New Zealand who's doing this. She's going to be recording, and also somebody in Australia who's been out shooting.
I've seen some Kofo, or I think it is.
Yeah, Kofo.
He captured the moon from New Zealand and I believe Florida. See, the issue with that is it can be used in both ways. They can say, well, the moon's 400,000 miles away, so you can see it from both spots on the globe because of the tangent on the radius point. But the star trail's moving in a flow horizontally. I'm sorry, but to me, well, I guess it would work on a disc shape, but it might even mean that it's more like a river.
I don't know. It's really freaky when you're looking at it.
But it does kind of look like that, maybe. Yeah. Well,
what happens is, depending on which direction the Antarctica station is pointing, you have it sometimes where it's going right to left in a slight downward angle, and others where it's going right to left in a slight upward angle, and others going right to left completely horizontally. And what you have on these footages that I have, on all of them, you have the stars making a completely straight line at the point nearest their horizon, but the stars at the very top are showing a distortion. But the distortion is the type of lens. It's not a distortion due to the actual sky displaying the stars in this way. It's a distortion from the lens, because obviously they're trying to capture as much of the sky as they can.
But round too, the lenses.
Yeah, well, this is a thing, Ronnie. If you think of the umbrella experiment, so you're spinning an umbrella, and when you're looking at the hub, that's the North Pole, and when you're looking at the edges, that's Antarctica. And no matter which way you look at the edge, they're going to move horizontally. If you incline your head a little bit, it's still going to be horizontally, but there's going to be a little bit of a dip or a rise. But it's still horizontally from the right of the screen to the left. And if we imagine that these are 180-degree cameras, that's a huge portion of the sky going right to left, completely tracing the horizon. No spin, no warp, no curvature, no smiley face or counter smiley face, nothing.
See, the footage that you're showing here,
Yeah, can you guys see this? I was just wondering.
Yeah.
See?
This is
That looks like it's
Gyroscopes.
been- that's doctored, right? That's fake, no?
Yes.
No, this is actually from Gyroscopes' Minute Physics 10 Ways We Know the Earth is Round Debunk thing.
Uh-huh.
Okay.
But yeah, that's what it's from. I was just looking at that, but I was trying to fit in what Antonio was saying with this because, I mean, this he shows the stars seemingly going around a certain point, and then as he pans to the right, the stars take on a clockwise spin.
Uh-huh. So something else to look out for, guys. If you want to look at this footage, find it yourselves. There's there's a lot of tricking that's going on, and one of the ways to discern whether you're looking at something tricked or not is when you consider the idea of masking or the idea of reversing the footage. On some of the footage, you have cars traveling, and when you look at the footage and you slow it down, you see that the cars are traveling backwards. So the red lights with the so
This is as real as the globe.
Something from this picture.
It's as real as the globe.
This image,
Yeah.
what I'm seeing on the screen here, Bob, is you've got the circular trails around, but the stars seem to be appearing over the top of this red dome. There's one star that's crossing over there. I don't know how that's happening.
Well, it's a this is a compilation stitched together, similar to the CGI that's used to create the globe.
Let's see. Can you guys hear it? Let's see. Can you hear it?
Just about.
no.
This is a 3D.
No.
No.
Okay, you can't hear it?
Now you got to put the output speakers or
Yeah, here, let me kick on my virtual audio cable here.
Okay, well, listen, Bob. In the meantime, what I'm going to do later today is I'm going to compile the video for the JLB thing. I'll keep it private just for now, but I'll share it with you guys. I'll share it with Jaron as well.
Just don't like it, or it'll go to a playlist.
Yeah, but when can we publish it? When can we publish it?
It would be private. So even if but I'm going to do this while I mull over your idea, Bob, which I'm thinking, do you know what? That might work really well.
I think so too. I think you should do that. I mean, it's only fair to give him a fighting chance and disclose the information and get the information out there. But that means I can publish this video that I made earlier in what, a week?
Okay.
Well, I don't know about that. I don't think he's going to try and give you guys any advantages.
No, that's true. but it's. I'll show it. I'll compile it, show it to you guys, and then you tell me what you think. I'm really in two minds because if I show this to JLB now, if I let him see it, what he will do, what I guarantee that he will do, is he will try to bring in questions of perspective, which is my reason for finding the equivalent footage from the northern latitude is that to destroy that argument and say, no, look, northern latitude, smiley face, southern latitude, no smiley face.
Right.
But if I display it to him, there's two things that can happen. He can just doubt it altogether, say it's all lies, if he's prepared in advance, or he can drop the debate, and I don't want him to drop the debate.
Well, if he did that, it would be perceived as there's no way he's going to do it.
Got too much ego to do that.
But he can claim ill health, a relative ill health, a break-in. You know,
if he does, Antonio, then everybody will know. You know what I mean?
Yeah.
I wouldn't worry about it, honestly, because if he does, he does. That's only admitting defeat. And what you have to do in this line of thinking is exactly where I'm coming from. It's like, so I'm going to drop this out there. I'm going to say, screw the preponderance. This gyro model is absolute proof, irrefutable. I am ready for the rebuttals of, well, what about the chamber doors at the bottom of the gyro cage, and what about the Schuler tuning? I'm ready for that. So, it's kind of like when you go to court, and you're an attorney, you never ask a question or never present anything that you don't already know what the answer is going to be or the reaction to it is going to be. And that's kind of the attitude that I'm going into this with. I can't find any other debunkings of the gyroscopic model that even hold a shred of water. And if I do, great. I'm not going to get all ego bound to it, but from what I can see, you know, what I've shown you guys, what I showed you guys earlier in the call, Ben, you weren't on at the time, but it's absolutely, gyroscopic proof is irrefutable in my eyes. Not only does it absolutely prove that the Earth is not spinning because of all the gyro experiments, you know, Rob Durham and stuff that he's done, but it also proves that there's absolutely no curvature to the Earth. And every rebuttal argument that they come up with, I've already got an answer for. And not only that, if you look at the gyroscopes under the conditions that are not using any type of Schuler tuning, even though we've already isolated those to specific, like automatic pilot systems, you can just take a standard gyro, and we have this, Rob Durham doing this on tape, where you just spin it up, and in a few minutes you should have a couple degrees of precession, but it never happens. It never happens under a wound, a motor-free one that's been spun up. It never happens on a motorized one. It never happens on an airplane gyroscope. You could go out and turn the artificial horizon on, you know, sitting on the lamp on the runway on the ground. And theoretically, if the Earth is rotating, then if you just sit there in that plane for, you know, 15, 20 minutes, you're going to see an attitude change, but you don't, and you won't.
2 degrees. It
Yeah.
should be the same as the declination, which is 63 miles per degree.
Right.
Or whatever, right? And you don't see that. The precession
No.
stays level when you keep the power source applied constantly. The failure with that experiment while trying to prove the ball was that they ran out of power with spinning a gyro, right? Correct?
Well, yeah, because originally Foucault did it, and Foucault didn't have anywhere nearly as well engineered gyros as we do today. You know, and plus we've also come up with other methodologies of propelling them. One of them is the air methodology that they're saying, well, the air discharge gates at the bottom of the gyro itself is actually giving a stable enough vertical axis, you know, pointing directly at the center of the planet, that it compensates for any gyroscopic error, which is absolutely ludicrous. That's just that notion is so retarded.
Can't find the center.
It's a theoretical construct, and you know, and so that's why I'm coming at it from all these different angles, and also, you know, showing the 8 inches per mile squared. It's all a theoretical construct. That's exactly what geodesy is about. You know, standard surveying uses a planar model. It's as simple as that. I've talked to so many people, Chris Van Mater, I've talked to the surveyors at construction companies, and I've looked into it myself, you know, knowing full well that the Earth is flat. And there's just no other way that this can be done, and nobody would ever compensate any type of engineering for this. So, you know, John LeBon's given us crap, or me crap, I guess, specifically for, you know, this whole preponderance of evidence thing. And like I said, it's like, well, okay, we can do better. And that's simply by hitting it with, you know, what we believe is absolute proof, and then being ready for any type of rebuttal. And that's where you got to be ready on, you know, on yours, Anthony, or Antonio. You're going to be ready. You know what he's going to say, and so be ready for it.
So what I'm thinking is, if I show it to him there and then, apart from anything else, I think it would be interesting for people who are watching to see it, you know, because when I came across it, I've been conceptualizing it first, thinking the way it should play is this. So I was then looking for something that would either display that or display that my thinking is wrong. So when I found it, I thought, oh, okay, here you are. You can't find it by looking for star trails or time-lapse of the stars. You can find it while looking for time-lapse of the aurora australis.
Right. And logic would dictate that if the world is flat, then you're right, Antonio. We should be seeing the stars that way, right?
Yeah.
But if for some reason we don't, if, let's just say, for whatever reason, that whole precept is false, then it goes back to, you know, the baller's going to go back to, well, see, this proves that the Earth is round, whatever. And it's like, no. As I've said many times before, you cannot use the same physics to debunk the flat Earth, you know, that you do to prove the ball Earth. In other words, you have to look at the Earth itself and the heavens above as two separate entities, and come up with another explanation.
Yes.
So
yes, absolutely. And
anything else would be inductive reasoning, saying an orange is round, so all of the fruit is round, because we've first seen a round orange.
Exactly. Yeah. Yes, I agree with that. So that's what I'm saying, and that is the danger that John's going to try and drag us both back into, Antonio, is the thinking of trying to apply ball earth physics. Even though he doesn't believe in the ball earth model, he's going to fall back on those methodologies to try and disprove anything that we say. And we simply have to be aware of that and be aware of how he's going to respond and already have the answer ready.
Yeah, so, he will do that with regards to the size of the sun. I mean, for me, this is an issue that's not being talked about enough. For me, the sun doesn't change size, and he'll be using that argument. But for me, the same things that what you just said applies. The physics is very different from what we're seeing in the sky to what we're seeing on the ground. We can test these things on the ground, but the sky is something completely different beyond our, possibly beyond our comprehension. Fourth dimensional. There's various possibilities to what could be happening to cause this sort of phenomenon.
Yeah.
I could. Because I think he's going to talk about the star trails, the southern hemisphere, the sun not changing size, daylight in Ushuaia, right? And
I have the answer for the sun not changing size or changing size, either one. That's actually.
I'd like to hear it.
Oh, it's actually pretty easy.
Hold your thought, Matrix.
Okay, all right.
Yeah, tell me, this is what we've been discussing.
You want to know too, eh, Ben?
Sure. I thought about this a long time ago, and I think I've got a pretty reasonable answer for it. And you've probably heard it before, but it's a phenomenon called atmospheric lensing. Okay, and what that means is that when the sun is the furthest point away from us, let's say sunrise, okay, and it's just coming around that corner into our view, and it looks very low on the horizon, okay? From our perspective, we are looking nearly horizontally to meet the sun in our visual perspective, which means that we are looking through the greatest amount of the densest amount of our atmosphere, the atmosphere closest to the ground. That is our perspective to it. And that atmosphere will have a magnification effect. And of course, there are several different things that will change that magnification effect, one being any particulates in the air, other would be any moisture content in the air, various factors like that, which means that sometimes when things are on the horizon, depending on atmospheric conditions, you will see things that look very different in size. And then conversely, depending on density, altitude, and other factors like that in the atmosphere, you may not have as much atmospheric lensing as you would be on, say, a more humid day, okay? So then you will get a resultant visual observation of sometimes the sun will look bigger and sometimes it will look smaller. And as it's coming towards you, as it's rising, it's getting to a point where your perspective is having to raise up from a horizontal level to more of a vertical level. And of course, at that point, you're then looking through thinner and thinner atmosphere, and the sun is also getting closer. So you're going to have less of an atmospheric lensing effect. However, because of the fact that the sun is getting closer, it's naturally going to compensate for that loss in atmospheric lensing magnification by sheer proximity. So there's your answer. That's why.
Yeah, I mean, I have thought about this, and I was trying to I looked at water magnification on YouTube, and you can make a magnifying lens with water.
Yes.
It's quite a simple experiment to do. So that's definitely something I've considered. It would be, because it's kind of giving a consistent magnifying effect. I mean, however it's doing it, I don't know, because the sun is like exactly the same size.
And the moon.
So it's interesting how it does that, and we also talked about the supermoon, how the supermoon appears to be much larger on the horizon. When you see, I've seen this myself.
Yeah.
Whilst fishing by the lake here, and you see the supermoon. It looks so much bigger in the sky, but when it goes overhead, it gets smaller.
Yes.
Sometimes it looks large when setting.
Exactly.
Maybe that's the difference between the two. Maybe due to the light itself.
Actually, Ben, I think you've just cracked it. When you look at the moon and it's very close to the horizon, it looks so huge. But we know it is further away than when it's above. And
but you're dealing with lensing that's making it look bigger.
Yes, and because the moonlight doesn't cast off as much brilliance as the sun, the atmospheric lensing doesn't happen in the same way. So we can see a crystal clear moon At night, also, there's less particulate matter and atmospheric conditions. On the horizon, you can see a moon that looks very clear to the naked eye, and also see that moon in the middle of the night, further above our heads, but it looks smaller. So if you think of the same effect happening with the sun,
Well, it does.
instead of the sun, yeah.
Well, I mean,
Yeah,
I
it's
filmed
yours.
it, so I was stopped in my tracks the other day at work because I saw the sun on the horizon, because obviously it is vastly far away and there's so much atmospherics that it's blocking the massive amount of blur that you normally get from the sun. That means you can't look at it. So you can look at it and it's enormous. I mean, don't get me wrong, on tape it looks tiny.
Right. and so that also verifies, you know, like on David's videos that he shows when the sun is going away and it's setting, it appears to be getting smaller. And then other people will produce sunset footage where that effect, we're not seeing that happen. Well, again, that's easily explainable because, say, the one that David was using was filmed during a high humidity day, and there's a lot higher magnification, atmospheric lensing going on.
That would explain that.
Or
That would
chemtrails.
absolutely
Someone
explain
tried
it.
to say that it was a fake video. That's a different way to look at it.
Or
Yeah, so
chem-
this
or
one-
chem- or
one of those
chemtrails.
clips is
When
one
there's
of
not
the clips is a fake video.
Yeah, one of the videos Dave has up
Yeah,
is
it's
real.
it's the one where it gets really small because there's no changing in the
Right.
foreground, just gets stuck. One of those is that, but the problem with I mean, what this is saying is that how the atmosphere gets the lower you get, and what it does do, it removes the glare. Yeah, the further the lower it gets, the more glare is removed. But what people like David, I mean, I spoke to David yesterday, and
Hey, Ben.
You're breaking up.
Ben, can you maybe kill your camera? Because I think you're having some bandwidth issues there. You're breaking up.
Okay, is that better?
Oh, now I hear you better.
Okay, so I spoke with David yesterday about, because I've been dealing with Jeffrey Cup issue and some of the things that he's been doing, and we discussed this yesterday, and now there's a problem with like the idea of believing that the sun's getting smaller based on the switches that they're using, and I was kind of going to I've kind of started making a video to address this issue, because I think the methodology that people are using is wrong. And I could share my screen with you. I could
Can you stop
and take you
sharing,
through.
Bob?
Can you hear me okay?
Yeah.
Yeah.
Can you stop sharing the screen, Bob, so Ben can share?
Oh, I'm sorry. I didn't even remember. I didn't even realize I was still sharing. Silly me. Stop sharing screen. There we go.